Hi guys, welcome back to lesson 18.2, finding the roots of a polynomial function. We are going to split this into 2 days. So the learning materials you will need is your Springboard book, pages 281 to 283, a pen or a pencil, and your calculator. Today we are just going to focus on the first part of this lesson, which is to know and apply the rational root theorem and Descartes' rule of signs. Okay, so let's get started. It says here some polynomial functions such as f of x equals x cubed minus 2x squared minus 5x plus 6 are not factorable using the tools that we've learned. However, it is still possible to graph these functions without a calculator. The following tools will be helpful. So these are the 4 tools we are going to use over the next 2 days. But as I mentioned, we are focusing on these 2 today. Rational root theorem, which is finding all possible rational roots. Descartes' rule of signs, which helps to find the possible number of real roots. And then in the next video, we'll talk about remainder theorem and factor theorem. Okay, so you basically need at least 3 of those tools, or all 4 of them if you want, to find these roots. So let's start with rational root theorem. Basically what this says here is if a polynomial function f of x has integer coefficients, then every rational root of f of x equals 0 has the form p over q, where p is a factor of the constant and q is a factor of the leading coefficient. So I kind of wrote that here in more clear terms than a sub 0 and a sub n. So p is all of the factors of the constant and q is all of the factors of the leading coefficient. So let's do an example. It says here the rational root theorem determines the possible rational roots, okay? So it's not saying that all of these are the rational roots. It's saying that they are a possibility that they could be, okay? So here's what we do. If we're given this quadratic equation here, what we would do is take the coefficient of the constant, which is -3. The signs really don't matter, but we're going to say that our p is 3. Okay, and the factors of that are 1 and 3, right? What 2 numbers multiply to give you 3? 1 and 3. Okay. Then our q is the leading coefficient. And again, this is over here. P is the constant. Q is the leading coefficient. So now let's figure that out. So our Q is going to be 2. And the factors of 2 are just 1 and 2. Okay. So then what we need to do here is this P over Q, and we need to write all of them as the positive or negative versions. So I'm going to kind of simplify this to be possible rational roots. I'm going to write it like that. And those are going to be plus or minus, and we need P over Q. So I'm going to do 1 over 1, which is just 1. Okay. Then I'm going to do plus or minus 1 over 2, which is going to be 1/2. Then I'm going to do plus or minus 3 over 1, which is just going to be 3 if you simplify. And then plus or minus 3 over 2. So 3/2. Or if you wanted to write it as 1.5 or 1.5, that would be fine too. Okay. So these are all of our possible rational roots, meaning, okay, again, remember that zeros, roots, x-intercepts, they all mean the same thing, right? Solutions. So these are all of our possible solutions. +1, -1, +1/2, -1/2, +3, -3, +3/2, -3/2. So basically, this is just giving us all the numbers that we can possibly work with, and then the other theorems and things are going to help us to kind of work our way down to what the actual rational roots are. Okay. So let's go ahead and take a look at a couple more examples of that. We're going to skip some of this stuff here and jump to page 282, where we are going to look at example A. And it just shows another example where they did the exact same thing we did. So they found Q first, actually, in this one, which is the leading coefficient, which is 1. So really the only factors of 1 are 1. So they wrote plus or minus 1. Then the factors of P, the constant, 6. Well, with 6, you have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So then when you go ahead and do your P over Q, they got 1 over 1, which was 1, 2 over 1, which was 2, 3 over 1, 3, 6 over 1, 6. So these were their possible rational roots here. Okay. So that's when we're going to go ahead and try 2 more, and we're going to go ahead and do those on the next page. So yours is right here, the try these A, that's what we're going to start with, but I'm going to do mine on the next page. So again, first, I personally like to find the P, which is 3, and the factors of 3 are just 1 and 3. Then we can find our Q, which is the leading coefficient, which is just 2 here. And I like to write out the factors 1 and 2. Now, when you write your possible rational roots, this is when I like to include the plus or minus, okay? Because you can do plus or minus 1 over 1, which would be 1, plus or minus 1 over 2, which would be 1/2, plus or minus 3 over 1, which would be 3. Oh, and this one's actually turning out the same way as that first example we did. And then plus or minus 3 over 2. And that would be your possible rational roots. Okay. All right, let's try one more here. And if you want, you can pause the video and try this one on your own. But we have our P is 5. This is also on page 283, number 4 in the Check Your Understanding. So factors of 5 are just 1 and 5. Okay. Oops, let's change colors. Then you have your Q, which is your leading coefficient, which is 2. Factors of 2 are just 1 and 2. So now a lot of these were pretty easy where there weren't many factors, but if you had something like 8, you would have 1 and 2 and 4 and 8. Or like the example A where we had 6, and so there was 1, 2, 3, and 6 were the factors. So it's basically just whatever numbers multiply to give you that coefficient. Okay, so now we're going to come up with our possible rational roots. And those would be plus or minus 1 over 1. So that's 1. Plus or minus 1 over 2, so 1/2. Plus or minus 5, over 1. So that's 5. And plus or minus 5 over 2. So that's 5/2. And that's it. Okay, so that's how you find all of your possible rational roots. And then, like I said, from there, we're going to use the other rules and theorems to help us narrow it down. Okay, so now let's go ahead back to page 282. And it says here, the rational root theorem can yield a large number of possible rational roots. As we just saw, even in just this example, there were 8 possible rational roots. Okay. So that's a large number of possible roots. To help eliminate some possibilities, you can use Descartes' rule of signs. While Descartes' rule does not tell you the value of the roots, it does tell you the maximum number of positive and negative real roots. So since we have all those plus or minus signs, it'll start to narrow down, okay, how many positive ones can we have and how many negative real roots can we have? Okay, So here's how you do Descartes' rule of signs. It says if f of x is a polynomial function with real coefficients and a non-zero constant term arranged in descending powers of the variable, so basically in standard form, then the number of positive real roots of f of x equals 0 equals the number of variations in sign, that's what we're focusing on, of the terms of f of x, or is less than this number by an even integer. So we're going to talk about that as well. The number of negative real roots of f of x equals 0 equals the number of variations in sign, but of the terms of f of negative x. Okay, so let's look at an example. All right, so first, it's going to ask you to find the number of positive and negative roots of f of x equals x cubed minus 2x squared minus 5x plus 6. Then it says to determine the sign change. So first you want to just look at the regular f of x function as it's given to you, okay? So you are looking for sign changes, and the first term is positive, the second term is negative. So that right there is one sign change, okay? Positive term to a negative term. Then from this one to this one, those are the same, so that does not count. Negative term to a negative term, no sign change. But from our third term to our fourth term, that is another sign change. So you're literally just looking, does it go from positive to negative or negative to positive, or does it stay the same? So in this case, there would be two sign changes. So there can be 2 or 0, because you always, as it said here, or less than this number by an even integer. So 2 or 0 positive real roots. Okay, so that's how you answer the first part. But then obviously we also have to answer the second part, which is about negative real roots. Okay, so that's when you go to step 2. Okay, and you have to change up your polynomial a little bit. So now you're doing f of negative x. Okay, so basically what that means is f of negative x. You are plugging in negative x for all of your x values in the original polynomial. Okay, so that would be negative x cubed minus 2 times negative x squared minus 5 times negative x plus 6. Okay, so I literally just plugged in a negative x for all of those x values, and then let's simplify. So negative x cubed is negative x times negative x times negative x, so that's going to continue to be negative x cubed. Okay, then you have negative x squared, that's negative x times negative x, which is going to be a positive x squared, but you have to multiply it by this negative 2. So that's going to end up being negative 2x squared. Then you have negative x times negative 5, so that's going to be positive 5x. And then you have the positive 6, which is not going to change because there's no x value. Okay. So now once you've done that, you again need to check how many sign changes there are. So from your first term to your second term, it's negative to a negative. So that's not a sign change. From your second term to your third term, there is a sign change. It's negative to a positive. So that is a sign change. And then from your third to fourth, they're both positive. So that's not a sign change. Okay. So that means we would have 1 negative real root. Now you can't say or 0 for this one because it's just 1 and you can't go down by an even number. So we're just going to say 1 negative real root. Okay. And that's what their solution was here. There are either 2 or 0 positive real roots and 1 negative real root. So you're just looking at the sign changes. Okay. On the next 2 pages, we're going to go ahead and do the try these be. So this example here, And then we're going to do number 5. So these are in your book on page 283. I'm just going to do them on the next 2 slides. Okay. So first thing here, we're looking for positive. So positive real roots, you just look at the equation as is. So this goes from a positive to a positive, no sign change. Positive to a positive, no sign change. Positive to a negative, so that's going to be 1. Let me write it under here, actually. 1 positive real root. Because there's just 1 sign change. Okay. Then we'll go over here and we need to make it f of negative x. So we're going to plug in negative x for all of those x values. So 2 times negative x cubed plus 7 times negative x squared plus 2 times negative x. Oops. And then minus 3. So now we simplify. And negative x cubed, again, is negative x cubed times 2 is negative 2x cubed. Negative x squared is positive x squared. So that's going to be plus 7x squared. Negative x times 2 is negative 2x, and then negative 3. So again, we're counting our sign changes. We have 1 here. Then we have another 1 here. Okay. So, and then we don't have 1 here. It's negative to a negative. Okay, so this would be 2 or 0 negative real roots. All right, so I'm going to have you guys go ahead and try the next one on your own, okay? And if you have any questions, be sure to bring them to class tomorrow because we are going to go over this. So we're just going to be going over the rational root theorem and Descartes' rule of signs, okay? So get some practice here, and then we'll do some more practice in class tomorrow. Have a good one. Bye-bye.